Hey guys, this is Mr. Fourth Dimension. Welcome to another episode of the Geo Project. We're going to work on triangle area stuff again. This time we're not going to do side angle side. That stuff is basically in place for now. We're going to do another formula. We're going to do side, side, side. So if I know the length of three sides of a triangle, there's a formula for finding the area from that. And I got it up right here. This is why I don't know that this is the algorithm we're going to use normally, because it looks like it might be too much computation. Hard to tell, because it does have just the one square root, except that if we don't, that is if we already know the length of sides. But comparing this to what we had to do to compute the area from an angle and two side lengths, this is possibly more work, because we're doing a square root, which I don't know how that compares to a sine, which is a trig function in speed, but we also have to do three subtractions, what is this, 1, 2, 3 multiplications, plus a division and some additions, plus we have to find all three distances, so it just overall probably is more work, especially if you didn't already have the three line lengths, but who knows, maybe there's reasons why this can be faster. So, we're going to implement it. And if we have to be in a situation where we know three side lengths for some reason, but we've discarded information about the points, then we'll need something that can find this area anyways, possibly. So that's what we're going to start with. So that is going to go right here. Real 32, geo, triangle, area, side, side, side. And for this one, we just take three side lengths, so it'll go side 1, side 2, side 3, of course. Side 3. Now, the first thing we want to do is calculate this p parameter, the half parameter. That is going to be side 1 plus side 2 plus side 3 times 0.5. So that's our p parameter, and then we're going to do all this work and see. Maybe we'll probably just do this in one line. I think that makes sense. So we want the square root of p times, what is it? P minus a times p minus b times p minus c. Right, so that's going to calculate the area from three side lengths. So let's put this to the test. To test this one, we're going to do triangle area, side, side, side. Let's pick three side lengths. So we'll start with a triangle that has leg of 2 by 2, and then the third leg would have to be, if I'm thinking of the right triangle, the isosceles right triangle. So this is 2.f times the square root of 2.f. Right, so that, something didn't work. Okay, so I called it ABC, and those should be side 1, side 2, side 3, according to our naming. Okay, that looks better. So the area of that is 2, huh? Is that right? 4 by 4 divided by 2. Yeah, so this, not 4 by 4. If you took a 2 by 2 square, you'd get an area of 4. Half of that should be 2, so that is right. Let's do another Pythagorean right triangle type deal. So this is like, these are the legs, 3 and 4, so a rectangle would have the area of 12. This should have the area of 6. And voila. So, looks like that's doing what it's supposed to do. We can do one more. I don't know the area that something like a isosceles triangle is supposed to have, but we can Google that. Oh, I closed my browser, but we will Google it as soon as I check it. Okay, so is that the area of an isosceles unit triangle? That is the question. Hold on. There we go. Isosceles unit triangle area. area of a right triangle formula. Isosceles triangle for you. Let's see. Special. No, not isosceles. Equilateral. I should be saying equilateral. No. Triangle with side 1. 0.43. That's what we're looking for. Alright, cool. Awesome. So I think we can declare that the side area is working. So what we're going to do is we're going to see if we can we're going to block out this version. And like I said, the next thing we'll want to do is put this all to the test and see which of these two options is better. We'll do it this way. So one of these will always be in power for this particular function. And we do distances from A to B. Distances from... Oh, this should be distances. Distances from B to C. And from C back to A. Whoops, make that a 3. And then it's geo triangle area SSS, side 1, side 2, side 3. Cool. So let's try this version of the 3-point triangle, or 3-point area. I want to see if I can do this without that, because I'm not sure, and I haven't tried it yet. So let's start with 0, 0. So I'm just not putting in the name of the geo point, is what I mean, because normally I put geo point 2D right there. I want to see if I can skip that. 1. Okay. Yes, I can. Cool. So that is 1/2. That's correct. Let's try another one. 2. That's correct. Let's try one more. 4.5. 9 divided by 2. Yeah, that makes sense. Now we need to make sure that the order isn't coming into play, which I don't imagine that it is. Nope. Let's try something like 4 by 3. That one should be what? We did this one's already 6, right? Yeah. Alright, so that looks like it's working. So now we have two different ways of doing an area. What we can do is later on we can take both of them and compare them in speed, but I don't know if I want to do that next. I didn't expect that we'd get done so quick with this one. I'm not sure. What did we do? I think it took longer last time to test all this stuff. Maybe I was more thorough with the area testing. I don't know. But I guess this is a short one because that's all we're going to do for the day. So this is Friday. Next Monday we're going to be able to look forward to setting up a timer and putting those two to the test and picking out our general 3-point area solution. Alright, so look forward to that and see you guys next time.